Hello guys, welcome back to my YouTube channel. So today's daily LeetCode question is minimum number of operations to make an array equal to the XOR equal to the k. So we are given an array and a k integer. So we need to make our array equal total array XOR operation should be equal to the k. So we are given a zero indexed array and a positive integer k. So we need to apply in this number of operations anytime so that we could make our array equal to the k, not array equal to the k, the XOR value of the array equal to the k. Okay guys, now choose any element, flip it bit in the binary representation, and which means 0 to 1 and 1 to 0. So that is the flipping of the bits. So we can do that operation any number of times, and we have to return the minimum number of operations required to change our XOR value of the all elements in the array equal to k. So this should be our condition. So now let's look into what the XOR actually means. Okay guys, now XOR actually means let's construct a truth table to our XOR. So if we have 0 0 values, then our output will be let x and y, and this will be our x XOR y. So here if our both values are 0, we will be getting 0. If one is 0 and other is 1, so we will be getting 1, and other is 1 and 1 is 0, so we will be getting 1. If both are 1, we will be getting 0. So this means you can clearly see that if both are in the same state or same values, so we will be getting 0 as the result. So let's look into some basic example. Let's 2 XOR 3 means what is the binary representation of 2 0 and 1 0. What is the binary representation of 3 1 1. If we construct XOR to these both, so these two bits are different, so our resultant will be 1. These two bits are same, so our resultant will be 0, which means the XOR of 2 and 3 is 1. So it means that there is only one bit difference. Okay guys, now let's look into an example part to understand this problem. This will be our first example. So here we are given an array of 2 1 3 4 and our value of 1. So the XOR of these all should be equal to 1. So how to make it? So first we have to make the XOR of all the elements. So let's make it. So 2 binary representation is 0 1 0. So 1 bit binary representation is 0 0 1. 3 binary representation will be 0 1 1. 4th binary representation will be 1 0 0. So here now we will be calculating the XOR operation of each and every column. So here we have 2 zeros which will result as 0. Here 2 ones which will result as 0. So 0 0 will be 0. So here also in the second column also we have 2 zeros and 2 ones which will result in as 0. And in the next column, the last column, we have 3 zeros and 1. 3 zeros, 2 zeros will make 0 because XOR operation is if they are equal, then the resultant will be 0. But these both will make 1. So our answer is this. See guys, 1 0 0 is our answer. So what is our resultant answer? Our resultant answer is 0 0 1. So here you can clearly see that these both bits are same, but these both are different. Okay guys, the XOR between these both will be 1 1 0. So how many number of minimum operations we need to make the whole array equal to the k is the XOR operations of the k and XOR of k. Okay guys, I hope you understand the example part. Let's look into approach part. So first we will calculate the XOR of all the elements. So this is our first condition. So our second condition will be if that XOR value XOR is equal to k, then return 0 because we need not to perform any number of operations, just it is already equal to k. Else we will just calculate the difference, the XOR operation between k and our value. So the above example, so for this example, if we see that the XOR value of this is 4 and our k is 1, so the XOR between k and 1 is, so the XOR of 4, the binary representation of 4 is 1 0 0. The binary representation of k is 0 0 1. So here if you count the one bits, number of 1 bits is the minimum number of operations to be performed to make the array equal to our k. Okay guys, now let's look into the code explanation. So we will initially declare an XOR variable and we will find the XOR of all the elements in the array. So let's look at this example only. The XOR of all these elements will be 4, right? We have already calculated before, so you can go and revise that. Now if our XOR equal to k is 4 equal to 1, no, then we will perform the XOR operation between k and our 4. So then we will be resulting 5. Yes guys, 5. So what is 5? 5 is nothing but 0 1 1 0 1. So here you can note of how many number of 1 bits in the XOR operation between 4 and 1 is the minimum number of operations required to perform to make these all k array values to equal to k. So in 5 there are 2 ones, so our answer will be 2. So here I am calculating the 1 bits. How many 1 bits are there? See, count value of z, and I will perform bitwise and left shift. So finally I will return k. I hope